Excellent, thank you. All right, welcome everybody to tonight's event as part of Engineering Heritage Week, coordinated by Engineering New Zealand. My name is Joe. I'm the MC for the evening, which is going to be interesting. We've got in-person audiences the same size as the number of people helping run the event tonight. So hopefully there's a fair few of you online listening in. So we've got a couple of really interesting presentations today. As far as the organisation of the session goes, we're going to have a few minutes from Simon Hall from the Mechanical Engineering Technical Group briefly in a moment. And then I will introduce our first presenter. As we go through the evening, we'll take questions at the end of each of the sessions. So our first presenter, Ian, will speak. There'll be a Q&A session, and then I will introduce our second presenter, and then there'll be a Q&A session at the end of that. And then at the tail end, we'll have a catch up for any final outstanding questions that might be or might still exist. So with that, I will hand over to Simon Hall from the Mechanical Engineering Group to speak to us briefly about the Mechanical Group and their work in Canterbury. Simon, over to you.
That's great. Thanks, Joe. So good evening, everyone. I'm Simon Hall. I'm chair of the Mechanical Engineering Group, which is, as you can see there, it's a technical interest group of Engineering New Zealand, also with ties to the Institution of Mechanical Engineers in the UK. So we're the technical group for anyone with an interest in mechanical engineering. So you don't actually have to be a mechanical engineer. You also don't have to be a member of Engineering New Zealand. Ollie's probably cringing as I say that, but for the fairly modest sum of $40 a year, you can be a member of the technical group and come along to roughly one event per month or thereabouts, sort of a mix of technical presentations and site visits. Understandably, most of our events have been online recently, but the other reason I'm here speaking to you tonight is that we're on the verge of actually having an active Canterbury branch. So I just spoke to a bunch of quite interested people last night. So we're on the verge of setting up a committee and actually having in-person mechanical engineering group events near you. We're also with an active group where we have an event in another region. We can probably organise a local live viewing, where you can all sort of get together and network and perhaps have a few refreshments and then view the online event as a group. So I'll just pop a couple of details into the chat there. If you're interested in either helping run a Canterbury branch of the Mechanical Engineering Group, or you're just interested in joining, there's link to the group page and my email if you want to get in touch. So yeah, thanks for that little opportunity to have a wee plug there, Joe. I'll hand back to you now.
You're welcome. Thank you, Simon. Okay, so tonight's first presentation is entitled Bottled Lightning, New Zealand's first public electricity supply, which is about the construction of a hydropower scheme for Reefton in the let's say the late 19th century, and we'll find out the exact date soon. Our presenter this evening is Ian Bywater, who's had a range of positions throughout the New Zealand electricity industry and for a number of environmental companies, and is the secretary of the Canterbury Heritage Chapter of Engineering New Zealand. And Ian represents the hydro turbine company Curo. With that, Ian, I will let you go to it.
Okay. Good evening, everyone. My story tonight will cover when, how, and why Reefton became the site of the first public electricity supply in New Zealand. When was in 1888. On the evening of August the 1st that year, a hydro station started generating. Its output lit the main street, Broadway, using arc lights and incandescent lamps, and ready to provide a supply to shops and houses nearby. History was truly in the making. My talk will briefly cover the historical background at this time, explain the why and how for Reefton, and end with the project of re-establishing a hydro station at the old site with a modern one after a 60-year gap. By the 1880s, the Industrial Revolution was well established. Invention exhibitions were held in major centres and are the forerunners of today's international trade fairs. These exhibitions displayed the products of the new technologies of the era. And in addition to this revolution was another, the start of the electric age. Foremost in America, Thomas Edison, George Westinghouse, and Nikola Tesla were leaders in this field. A recent cinema film, The Current War, dramatized the work of these pioneers and their different view of whether direct current or alternating current should be used for generating electricity. In Britain, Joseph Swan's laboratory was also experimenting with uses for electricity. Last year, the UK had 2 postage stamp issues commemorating the Industrial Revolution and what they called the Electric Revolution. The Electric Revolution set here celebrates Faraday's electromagnetic induction experiments in 1831, the transatlantic telegraph cable between America and Britain in 1858, Swan's patent for the incandescent lamp in 1880, and Britain's largest steam power plant opening at Deptford, London in 1889. These were wonders of the age. 2 means of generating electric light were the electric bulb, light bulb left, and the arc light. An incandescent lamp uses a glowing hot filament in an evacuated glass bulb. The arc lamp, on the other hand, is a visible arc of ionized air between 2 electrodes. The arc is similar to natural lighting, and you can see where the term bottled lightning might have come from. Prince in this story used the term, and maybe he invented this description for the light bulb. Both Edison and Swan claimed to be the inventor of the incandescent lamp, but then came to a mutual agreement to commercialize it as the Edison lamp, as seen in this advertisement. We now visit the town of Reefton and the man who became most involved, Mr. Walter Prince. We know he came out from Britain in the late 1870s and found work in Dunedin with a company supplying mining equipment. He must have had some knowledge of electricity, for in 1884, he supervised installing electric lighting and motors at the Phoenix gold mine in central Otago. Prince first visited the gold town of Reefton in 1883 to investigate using the Anungahua River as an energy source for electricity generation. He also travelled to many other locations up and down the country at the time, whenever an inquiry came from those in having electric lighting. Reefton investors has asked Prince to come on his second visit to give practical demonstrations. He came with a 1 kilowatt dynamo and connected to a steam engine at Reefton's brewery to power lighting in 4 of the bars along Broadway. He also held public meetings at the Oddfellows Hall, which still exists, charging 2 shillings or 3 shillings if you wish to sit in a front seat. That's about $10 or $15 in today's currency. Prince extolled to his audience the wonderful benefits that electricity could provide and proved himself to be a good salesman and a true visionary of what the electric age would bring. This published quote from the Anungahua Herald shows his belief in a future where not only the rivers, but waves, tides, and wind would someday be prime sources to generate electricity. He was a true visionary. On his first visit, Prince had made a plan of how to offtake at Black's Point that would supply water from the river leading to a power station site on the south bank opposite the town. Whoops, sorry. The route would require a tunnel, beg your pardon, at one point in the bend in the river, and otherwise would use the steep land face on one side and a concrete containment wall on the other. The head race would then transition to a timber flume to cross open ground to the exact power station site. His scheme was adopted and 20,000 shares were offered at 5 shillings to raise the expected capital need of £5,000. And that in today's currency is over $1 million. Prince invested as a shareholder and he was retained as the company's engineer to supervise the project. The left photograph shows the first powerhouse. Top left, and surrounding buildings, one of which no doubt was the power station's superintendent. The right photo shows the foundations of the last 2 power stations, and which today are Heritage New Zealand Category 2 site. So the site at Reefton has had a succession of power stations. The first of 20 kilowatts operated until 1908, when a replacement station was built beside the old with a capacity of 100 kilowatts. A further increase in capacity was made in 1935. The Grey Electric Power Board then took over ownership from 1946 until decommissioning in 1961. Then in 2010, a group of enthusiasts formed the Powerhouse Charitable Trust to raise awareness and the funds to have the hydro scheme reinstated. The formation chair of the trust was Greg Topp, a former electrician with the West Coast Electric Power Board, now Westpower, and a recent owner of the local electrical retail shop on Broadway. These 3 photos show how the tunnel exit towards the end of operating. So that photo was taken in 1938. It shows the tunnel exit that I spoke about. Also, you can see that although potentially the station was still operating at times, debris was forming in the head race. And this shows a picture of the middle picture of how nature has taken over during the years when the station was no longer there. And the right-hand one shows the beginning of work to restore that part of the head race. This is a recent photo of the tunnel site on the exit side. The head race is still running along the face of the land here, and where previously there were concrete panels, those were too decayed to be used, and therefore a substantial berm has been put on that side. This is a picture of the original intake point at Black's Point. and will be used today. The headrace leading to the tunnel, you can see old concrete here, replacement concrete here, and rock placement on the land side. So the design for a new power station is to have a 250 kVA modern axial flow turbine, generator supplied from Turab, Sweden, who also supplied the draft tube. The right-hand picture shows more detail about the turbine, four-bladed variable pitch axial turbine, and the generator. The station operates with a head of 8.5 meters and a flow rate between 1.2 and 3 meters per second. Here am I standing with Greg Top in a dry storage shed where the turbine, or turbine generator are stored. And this is some of the timber that we use for the open timber flume. The design of the new powerhouse building will replicate the style of the old building, and a removable section of the roof will allow the equipment to be installed once the building is completed. As time and funds permit, the Trust is looking forward to a commissioning later this year or early next. So in conclusion, my involvement in this project sent me looking for examples of the earliest public stations elsewhere. There's Godalming near London was 1881. Manhattan in New York in 1882. Timisoara in Romania in 1884. And La Roche in France in 1885. And of course, Reefton can be added to that list in 1888. So in closing, I would like anyone to get in touch if they have further information of Reefton's old power stations. Thank you.
Okay, so we'll start with the people in the room. Are there any questions? I've got one. When they first built this thing in Reefton, and it was the town power supply, was it mostly just powering domestic and street lighting, or was it used for industrial power? Or
very early days, 20 kilowatts DC. Mainly, the town was thrilled to have street lighting, and then the use of a few electrical motors would very early days.
Electric light was a pretty big change at the time, wasn't it?
What is surprising is how close we were to the developments which were surging ahead elsewhere. And that is extraordinary. If you think of how difficult it is in the 1880s to get to Reefton, devise a hydro scheme, implement it, and get it going. I mean,
it's quite astonishing, really.
Stewie,
cutting edge for the new technology. Excellent. Holly, were there any questions from our internet audience?
There are indeed. First question, is the recreated system complete and now generating power for the town?
The answer is no. Site work is still proceeding. The plans for the powerhouse are completed, and the head race is still being constructed. So we're looking at an early or a late 2022 commissioning or maybe spilling over into 2023.
Thank you. Another question here. Moira is wondering how much of the water race infrastructure was already in place for mining in Reefton, and when was this installed?
There was no water race before this scheme was thought of, if I understand the question correctly. So it was a concept to how to bring water to Reefton specifically for electric power generation.
Great. What voltage and frequency was used originally?
To be honest, I don't know that the answer. Well, the frequency is 0 because it was direct current at that stage.
Thank you. And just one more here. How did Reefton compare with the Bullendale Power Scheme near Skippers, 1886, according to the DOC website?
This is a low head hydro station, and the one you're referring to, I'm sure, is a high head Pelton wheel generator. So that would be the major difference between the two sites.
Great. There are a couple more questions still coming through, and please feel free to send them through. Conscious of time, maybe we'll hand over to Ian, number 2, to kick off his presentation, and we can get back to some more questions at the end.
Thank you, Holly.
Thank you, Ian.
Yeah. So, yes, and thank you very much, Ian, for that very interesting talk. For those of you online, as I said earlier, we will have a bit of a catch-up time for questions at the end. So if you do have any, just please keep typing them in. Okay, so our second presentation tonight is entitled Dunedin's Cable Car System, a bold venture in the antipodes, and is about the history of cable car public transport in Dunedin. Thank you. With this presentation has 2 authors, only one of whom is here with us tonight, unfortunately. Ian MacGregor is the presenter.
That's slides and that's red dot.
Yes, so Ian is a member of Heritage New Zealand and the Tramway Historical Society. He lives 80 metres from the Murray Hill cable car line, which forms part of the topic of tonight's talk. And I'm sure he'll introduce himself further if need be. The co-author of the talk is Miles Pierce, who is not physically present, but I'm told may be logging in. Miles was Principal Electrical Engineer of the Victorian practice of GHD, has a long-term interest in engineering and industrial history, and is a committee member and past chairman of Engineering Heritage Victoria. So,
there you go.
If Ian's ready, I will hand over and let you have at it.
Okay, thank you for that, and good evening. I'd like to start with co-author Miles's map of Dunedin showing the initial cable car lines and some of the extensions. This is the main street of Dunedin running through here, and the first line to be constructed was the Roslyn line, starting at this point, going up the steep hills and finishing towards the top of the town belt in 1861. That line was extended up the hill and down this route, and that operated from 1901 to 1906. I've got an itchy nose, excuse me. Unfortunately, the Public Works Department, a very large government department, did not agree with the operation of this with public passengers on due to the gradient of 1 and 3.5. So this was the cable car house, but passengers had to get off at this point here. In 1906, the line was extended through a new route with a gradient of 1 and 4.2 down through here to the engine house. This line also had to have a foul brake system running down through here, and we'll see that later. The second line was the Mornington line running up High Street to the terminus in Mornington, and then the very famous Murray Hill car line, with a steep gradient of 1 and 3.5 down to the public streets here and up to the Maryhill terminus. The next line was the Elgin line, and that ran from 1906 to 1910. And I'm afraid I have to admit it wasn't too successful. There were too many curves in the line, particularly in this area, another right-angled curve up here. So the cable running underground was subject to quite a lot of curves and twists, and the tunnel also didn't last too well. So the fourth line was the Stewart Street Kaikorai Valley line. That was closed in 1947 to make way for a major access into Dunedin from Kaikorai Valley on this route. And I suppose I'd have to admit that that might have been justified. So let's start and look at some slides. We have the original cable car on the Roslyn line, just a single track. And if you can imagine very well, there is actually a slot in the ground, just 7/8 of an inch wide. And there was a connection between the cable car, the gripper plate, and the cable running in the tunnel here. George Duncan was a member of the engineering firm consultants, Reed and Duncans, and he invented the let go curve, because at this corner here, there was very steep and the cable car had to go around a corner. Up until then, in San Francisco, if the cable cars came to a corner, they let go of the cable, coasted around the corner, gripped it again and carried on. But you can't do that on Dunedin steep streets. So he invented the pull curve. Here we have a diagram of the first cable car on the Roslyn line, that's street level running through there. And we have a wheel here interconnected with 2 screw rods. And as the brake was applied, the cable was released down here. And alternately, if you wanted to pick up speed, as the cable was picked up, the brake was undone. We'll just have a quick look inside the tunnel. And you can see street level here. Here's the central gripper plate coming from the car down to the gripper in here. You can see a cable being held there. That's the one that's moving a cable car, and the alternative cable in the opposite direction is running on that wheel. Part of his design for taking cables around a corner was that pulley there, so the cable could actually run against that pulley when it wasn't held by the gripper. Another very unusual feature, as far as I can tell, was the fixed chafing rail in here. And there was a roller at the side of the centre gripper plate, which ran against that chafing rail. And my theory is it was to stop the central gripper plate from bending. That was done away with by the time we came to the Mornington and Maryhill lines. And something I've noticed, particularly in the first 2 or 3 decades, was continual improvements in lots of components of the cable cars. Well, from that small cable car, we have the modern cable car. This was built between 1906. It was built between 1906 and 1908. And it ran until 1951 when the whole system was closed down. When that happened, it was the last steam-powered cable car system in the world. The screw feeds that you saw in the centre of the gripman's well before, they've gone, and we've now got lever systems. We've also got 2 brakes running here. Before, we only had the 1 brake and the lever to operate the gripper. And there's a totally new device here. This was to apply the fell brake. The cable car is much longer than the small one. We've even got 2 rows of seats through here, and we've got doors to enclose the cabins, which didn't exist on those original cable cars. This is the fell grip rail running down here, and you'll notice it's sitting proud of the ground, and the next slide is looking underneath here. And it's taken in a maintenance well in the tram sheds where the men doing the maintenance could actually stand upright. This is the fell brake in here, and it came in sideways onto the fell rail. This is a gripper. And despite the photograph being taken in very early 1950s, this strikes me as being a very simplistic one compared with other photographs I've seen. And that's the slipper brake there acting on the rail at road level. Outside again, you had to have lighting at night, and this was the kerosene light that went on the front of a cable car. There was a much smaller one inside in the gripman's well, and it generated a lot of fumes. And very quickly after that first cable car was built, there had to be a vent put in the roof to get rid of the kerosene fumes. And this is the roof vent that was put on the original cable cars. It stayed there after 1922 as a decorative ornament on the roofs. 1922 was when they changed from the kerosene lighting to a battery light, which had to be recharged on a daily basis. And you can see that original battery in the cable car that's reserved up in Cable Car House in Mornington. That's there today. Right, we'll swap to Mornington Line now. And this is High Street in 1862. It's still being formed. There's a manual excavation going on up here. And you had to have the formation completed before you can put in the cable car line. And Roslyn had been built with just a single line to start off with passing loops. The Mornington line was built just a year later with twin tunnels. And you can see the construction of the tunnels was a railway line bent into that shape and then concreted in, and a lot of timber here. And when I saw this drawing 2 years ago in the Hocken Library, I was horrified at the amount of timber that was in the tunnels. And this is ground level through here with the slot through here. These timber beams ran the full length of the tunnel, jointed obviously, and with steel plates running on top. They were 2 inches, 50 millimeters wide. The slot was there. There were also timber beams running the full length of the tunnel and with gravel sitting on top. And remember, this is 1883 when the line was constructed, and all the streets were gravel. In 1903, there were over 50 dray loads of mud removed from the tunnels of the Mornington line. Perhaps not surprising, and remembering the gradients, there were about 1 and 6.5. Inside the tunnel, there was a major change from the Roslyn line to this wheel and a series of them to take the cable sitting here around a planned curve. And I'm very concerned about this connection of timber up to the timber surfacing of the tunnel. There were screw connections. In detail, if you blow this part up, you can see screw connections here and a red text which says screws connections as opposed to nailing. There are a number of problems on this curve, and I'm not surprised because I think with time, this probably got loose and gave problems. That was taking the cable in plan view. This is taking the cable in elevation view from the horizontal up a slope like that. And there were depression pulleys used to do that. If we have a look at those 3 pulleys sitting inside what is a channel, there's a little oiling cup here. And I can't understand how they got the spout of the long oil can into there to oil it. And it's not what I remembered. This is what I remembered from the Mary Hill line. In school holidays, I used to do the shopping, to go up and get fresh bread and meat daily at Mornington Little Shopping Centre. And I would see this going on commonly on the Mary Hill line. By then, there was a cup that got screwed off the end of the pinion holding a pulley. It was filled with grease out of the can and then screwed back on. To me, this photograph is quite significant because there is another pulley system here, depression pulley system. And apart from the Mary Hill line, it's the first time I've seen evidence of 2 sets of depression pulleys fairly close together. And I'm quite concerned about the pulley system because I think the deflection angles, both in plan and in elevation, were too severe. This is taken on a ski lift, and despite the fact that the towers are a long way apart on this, the deflection angle between those pair of pulleys and those pair of pulleys is only 2 degrees. I printed this off and measured it. I've done similar sorts of measurements on the Mornington, Roslyn and Kaikorai lines where I've had photos available, and it's a very hairy process, but I was picking up angles of 25 degrees for deflection angles between adjacent pulleys. So the cables, I think, on the cable car lines in Dunedin were subject to big stresses when they went round pulley systems. The cable life varied from 27 weeks to 43 months. A good specification was necessary, but going through papers passed on their target 80 times, it wasn't always followed, and Dunedin City Council would sometimes go for the cheapest price. The British and Canadian cables were best. In World War II, they couldn't get them, and so they had to make do with American cables, and they didn't have the life that the British ones did. And they started to bunch after about 9 weeks. The bunching on the American or Canadian ropes or cables didn't start for over 12 months. Bunching when there was a single individual wire would break and then form a bunch around here. That would then get up behind a gripper and it would drag the cable car forward. In 1956, one car got dragged right up to the Mornington terminus when it crashed into another cable car. I can remember that, but there wasn't much damage done, fortunately. And pop-outs was another problem. This was actually caused by a gripman's error. But basically the causes of pop-outs weren't very well known. Okay, from cables, we've now go to cable cars. This is a drawing only about 1 year older than the Roslin first car you saw with the screw feeds. Screw feeds had gone and we're back to the gripper system with, of course, a mechanical advantage. This is one of the grippers that you see, and there was a hole in the floor of the cable car, which is floor, that's the cable car floor through there. It was about that long and about that wide, and this whole mechanism fitted through there. The lever would lift the cable up using the bottom jaw and clamp it against the top jaw. Set in the jaws were dies of soft metal, and they would normally last about 4 weeks and have to be replaced. But with one bad cable, the soft dies, metal dies, are having to be replaced on a weekly basis. Interesting mechanism in here to transfer the force from the cable to the cable car. There's a yoke running across here. There's a collar and a pin each end, and there was a gap in here. And that was in case there was a variation in the position of the slot in the tunnel. And so this whole system could move sideways if the slot was out of position. And so this is a picture of the actual first cable car and also the trailers which ran on there. When this system closed, I'm pretty certain it was the only cable car system in the world still running trailers. Okay, we move on to brakes, and this is a slipper brake here on a trailer. Conductor just wound that, tightened this up, and the brake was applied. And 70 years on, we can still see that same system working here on a trailer with that brake system and that vent system there and the slipper there. This was a 1911 requirement of the Public Works Department again. They were not happy with a trailer behind a car. They thought the trailer might run back downhill. And so they required an automatic brake that would work. So this got attached to the back of the cable car when it was being towed uphill. And either it could be applied by the gripman in the cable car, or if this broke, then a ratchet was automatic, or pawl and ratchet was automatically employed to brake the trailer and stop it from running back down to the exchange.
5 minutes, yeah.
Thank you. This is a pawl and a ratchet in there, photographed at Ferrymead. This is the third wheel system, and it was a wheel brake in here. I couldn't understand the drawing when I first saw it. And sometimes now I know in photographs you can just pick this up. But both Miles and myself independently came to the conclusion that initially there was only one braking system on both the Mornington and the Maryhill, in the Mornington and Roslin cars. So it's another example of ongoing improvements that there were then 3 brakes. How do you get the cable up into the gripper? Originally, it was hooked up by putting this hook down through the slot and hooking the cable up. It was quite strong work. In 1888, Loudon, the tramways engineer, changed that. He put a dip in the cable, in the line. The cable car came down through there, tilted down, and the cable was fed into the gripper automatically. Another Public Works Department requirement was to stop the trailer from travelling all the way back down to the exchange a mile away. And he required that there be these points coming through here to divert any runaway out into the grassy area over here. We can date the photograph to between November 1912 and mid-1914 due to the Charabanc, which replaced the Elgin Road cable car. Was at first accepted very well, and it was a total disaster, but then it was a bust, so what else can you expect? So looking backwards and forwards, we can be very proud of Dunedin Engineering's consulting firm, Reed and Duncan's Limited. There are a lot of inventions which they did and which we haven't had time to talk about, and which they got credit from Halliday, the original inventor of world's street running cable cars. The red pine in tunnels was a bit of a problem. Trees in New Zealand says it should never be used underground. And as I've indicated, my opinion is that the cable deflection angles were too great. The capacity of the cable cars and trailers was fantastic. In 1890, they actually used 2 trailers, but there were a few public complaints, and then the Public Works Department banned that. 1950, for Royal Tour, 201 passengers. How they managed to find the exact number is beyond me, very difficult to measure. So looking forward, I'd like to suggest that these figures here be used as design loadings for the proposed reinstatement of the Mornington cable car. Winding machinery might have to be a bit stronger, but that's probably about all. 3 braking systems with 1 directly onto the road, far superior to buses. Right. And the fast cable car loading and unloading is unbelievable. I can remember standing at the bottom of High Street when buses started to run. One person gets in the front and gets his ticket nicked. They had to put a conductor on the back to do the same at the back. It was still extremely slow. And so I've no doubt, having seen both systems, that on the steep Dunedin streets, the cable cars are vastly superior. Then think of the energy efficiency. Buses brake all the way downhill, waste of energy. You've got a counterbalancing system. And once they changed from steam, coal-fired steam generation in 1919 for Mary Hill and 1925 for Mornington, we've got clean renewable energy. The systems were 100 years ahead of their times. And the cable cars replacement, those trolley buses, they only lasted 31 years. Mornington and Maryhill systems were still going strong when they were closed after 74 years. And I think the buses should be blushing, as should the 9 out of 12 city councillors who voted against retaining Mornington and Maryhill lines. Excuse me, and that's my ticket from the last day of cable cars.
Excellent. Thank you very much, Ian. Not a fan of Dunedin City Council?
No. And I was at the meeting that the local hairdresser Ted Pictures organised to try and retain them. That was when I was in about the 5th or lower 6th form, I think.
That would be year 11 or 12.
Oh, I can't do that.
I'm still calling it 5th and 6th form when I was at school. Okay, so let's start with online questions this time around, shall we, Holly?
Absolutely, no problem. We've got a few comments in there saying great historic images. Thank you for supplying those. It's really awesome to see them, and it would be great to see cable cars make a comeback. A question here, was the cable just feathered by the gripper, bracket like a clutch gripper, at intermediate stations, or did the haulage machinery stop?
No, the haulage machinery was continuous and the cable was continuous, and you let go of the cable with the gripper and then connect it up again.
Thank you. That's the only questions we've got online at the moment. Just a reminder to those, if you do have any questions, you can pop them in the chat panel. Perhaps we'll swing to the room if you've got any there.
Thanks, Holly. I've got one first. How did they go the other way? Did they have separate lines out and return, or did they change the direction of the cable? Or
did you cut this off? Yeah. No, the cable was continuous in the main direction. It's perhaps worth noting that the length of the Mornington line was about 1 mile. So you've got 2 miles of cable, but then I worked out you've had something like half a mile of cable going into the cable car sheds, going through the winding machines and coming back again. So that was very much continuous. What was the rest of your question?
I'm just wondering, like, obviously they can take the cable car in one direction by clamping onto the cable and it follows along. But to go back again, did they have a separate line, or did they turn the cable and run it the other way, or how did they do that?
Can I go? If I can go back to a photograph, I can show you that. If we look at this diagram here, this is when it was right-hand drive. Duncan thought that New Zealand would convert to right-hand drive like the Americans. So he built the Dunedin line like that. It remained like that until 1929. So what we've got in this system is the up line and the down line here. The cable is running up here, across the street in a tunnel, into the winding gear in the bottom story of the tram sheds, coming back out again and going down that line there. So the cable car with the trailer behind it went up here. The trailer was stopped there. The cable car moved up to there. And then the cable car ran back down on the down line. And then the trailer came from here down this line. You'll notice no slot there, and came in behind that. And it was a very similar process down the bottom. Now, that was a major improvement on what happened in San Francisco, because and initially in Dunedin, because they would run the cable car right up onto a turntable there, turn it round about 1/8 of a circle, and then push it off the turntable and down onto the down line. So this made use of gravity. So it was another Dunedin invention. So that was how it was swapped over.
Excellent. That's cool. Thank you. That does answer my question very clearly. Any questions in the room? Yes, yes.
I'll get you speaking to the microphone so people online. Was much of the machinery manufactured in New Zealand?
I can't answer all of that question, and there's been quite a lot of confusion of that over the years. For the Dunedin line, the cable cars were manufactured by Cousins and Black. They were carted by horse and cart to the bottom of the Mornington line. They tried out first on the Roslyn line. They worked admirably on the Roslyn line. Then they were taken over to the Mornington line and installed there. Strangely, the trailers came from the United States, but they would have been much more simple to manufacture than the cable cars. The Roslyn cars, some of them at least, were made in Dunedin as well. The winding machinery, I don't know, but bear in mind, Dunedin was a centre of gold mining in central Otago. There was much heavy engineering in terms of foundries and engineering works there. So there was the capability of doing quite a lot of that work. And there was one case that happened in 1948. The big 10-foot, 2.5 metre diameter wheel had wooden segments and then cast iron segments and then wooden segments right around the perimeter. In 1948, there was a cable operating fault, and there was a lot of friction across the top of the idler wheel, and the timber segments in there caught fire. And they called in the fire brigade to put it out. It happened fairly latest in the afternoon. They worked right through the night to get new timber segments in, and the system was operating again in the morning. So that indicates very fast, efficient work. Could we do that today? There's another example. No, we'd have Osh and everybody else and things. There was another case on the Mary Hill line. There was an official opening for the public on a Saturday, and about 4 days later, probably a crown pulley where the cable came up and onto the horizontal, that broke. They got that recast within a couple of days and reinstalled. And so 3 days later, the Mary Hill line was up and operating. When they came to replace the Mary Hill tunnel, this is example 3, there was a delay of 2 years because they went to a Christchurch firm to get new points made. And it took the Christchurch firm 2 years to get the points made. And there was a 2-year delay in reopening the line. So there was a lot of work done locally, but they're also introduced components. The electric machinery, which replaced the steam-driven stuff on shore, was made overseas.
Excellent. Any further questions?
Just a housekeeping matter. You spoke about the debris that got into the tunnels. What was the method of cleaning them?
I don't know. The only method they would have had was to open up the manholes along the way. If I can, well, that's not working.
Just use the arrow if you need to go back.
Oh, okay. That was going to be a bit slow. If we have a look at the photograph on the rosin line, I haven't seen that, but you can just about work it out. There were manholes over all the main pulleys, all the way along. So these could have been opened up and they could have scraped the dirt out. That's the only way I can think of doing it. It might have been possible to wash some of the dirt out by putting in hoses. 1903, when that happened, it was privately owned, or it was Mornington Borough Council. There had been an argument between the owners of the cable car system and the Dunedin City Council as to where all the wash water, there was drainage getting in here, had to be got rid of the tunnels all the time. And the City Council said, no, you can't put it into the sewers. Then the operating company said, but the gravel is coming off your streets into our tunnels. And I'm not quite sure who won that argument, but these were available to help get rid of the material. Now, right down the bottom of the Mornington line, there was a tensioning pit, and it was about that high, because I've seen a photograph of a man in it bending over, and he is busy pumping out water with a lever when he's bent over, and they could have got rid of quite a lot of dirt there. They would have had to take it along the entrance tunnel under the road and then up through a manhole that came up in the footpath. The manhole was just big enough for the man to fit through and no more. But because there'd been a fire in 1903 and the whole of the top story of the Mornington tram sheds and all the rolling stock bar one trailer were lost, they had a period of 1.5 months to clean out the tunnels. And in that time, they got the line running again in temporary rolling stock. So they had a bit of time to do it.
Yeah. Fascinating. Thank you. Holly, are there any more questions floating in from our online audience?
Yes, a couple have come in. What speed did the cars travel at?
That varied. The rosin line, from memory, started at about 5 miles per hour. And the final Mornington speed, I think, was 10 or 11 miles per hour. I've got the figure in the paper, but it kept on changing. There was an increase in speed of about 2 miles per hour from Roslyn to the Mornington line. And then when they changed from steam to electricity, there was another increase of 1 to 2 miles per hour. And I think the final figure was about 11 miles per hour. It wasn't that fast because my father, when he got off the Mary Hill cable car, and all the men, they just took running steps when they hit the ground. And it was great because if there were no women or children getting off the cable car, particularly at the Byron Street stop where we got off, the gripman didn't have to stop the car. And at that particular stop, if they stopped the cable car, they had to use the ratchet and pull. It was 1 and 6.5 gradient. That's quite steep. And I can remember the gripman with his foot on the quadrant, actually pulling as tightly as he could on the grip lever to get the tight tension of the clamping back onto the cable at our stop. And the next stop up at Carson Street was just as bad. I rang one of the girls who lived in Carson Street. I knew when we lived there. I said, hey, did they use the gripper there? She said, what? You don't expect me to remember that, do you? So that wasn't much use.
Was there a communication system between the gripman and the haulage machinery operator in case of a gripper binding on the cable?
Oh, I like that question. Yes, it was installed about 1900. And in those days, they had telegraph poles or power poles along the sides of the streets, a footpath. And probably every quarter or fifth of the way along the line, there was a box about that long and about that high and about that wide. Now, it's described in 1900 as having a telephone inside. And what you could do was to stop the cable car, or if you couldn't do that, the conductor would hop off and let the cable car carry on. And he'd go to the signal box and ring through to the powerhouse or winding machinery operator, and he could stop the cable. There is the case that happened on the Mornington line when somewhere around 10 or 11 in the morning, there was only one conductor available. So he'd go up on the up car to halfway up, get off, cross over the downhill line and carry on down there. And just after that crossover had happened, there was a bunching behind the cable car, and there was nobody left to hop off the cable car and press one of the emergency buttons. And so that cable car got taken right through to Mornington terminus. Now, somewhere I've read the same thing was done, I think, about the 1930s, and I haven't quite sorted that out. There may have been a replacement. And in 1900, I'm not too sure, but telephone would be what we understand by now. So there's still a few questions in my mind about that system. Oh, and there was another system, which I'm going to add to the written paper. One of the operators in the winding machinery room, he had two strings coming down there and a string across underneath the cable. And top piece of string went up the top of the timber beam, the roof, ceiling, and down to a bucket. And if a bunch came through, it cut the little string wire, the bucket fell to the ground and the noise alarmed the operator. And so there was a second backup system to stop the cable. That was on the initiative of the cable car operator, not the Dunedin City Council.
Simple but effective.
Yes.
Any more questions there, Holly?
Yes, there's one more here. In the cars where the driver or gripman stood in the middle of the car, how well could they see the traffic in front of them?
Somebody's read the paper, the part of the paper that I haven't published. Yeah, not as well as we would like, I'm afraid I have to admit. There was a very sad case of a maintenance worker with his head and shoulders in one of these manholes that I've just showed you. And it was immediately after the cable car came around the curve and down onto Queen's Drive. And the man in the manhole wasn't seen. And the cable car went into him. It was a fatality. And then the evidence that came out, it was around about the 1880s, 1900. It was said that the visibility right in front of the cable car wasn't that good. But the operator had been disobeying instructions. The maintenance man had strict instructions from the manager who had taken him through to do the maintenance several weeks earlier and had been told not to do that sort of thing before. After that accident, it appears as though there are always two operators to do the maintenance work. Mm-hmm. And I'm wondering if what I saw on the Murray Hill line in the 1950s was always two people doing the maintenance work was a result of that accident half a century ago.
Thank you. They've made a comment. Yes, they haven't read the paper yet. And that seems like that's all the questions online.
Excellent. All right then. Are there any further questions in the room? No? Okay then. Well, thank you everybody here and online for joining us for this session. It's been quite fascinating. Thank you, Ian and Ian, for your two different talks. Deeply interesting. I had no idea the cable car system even existed in Dunedin back in the day, and I grew up just up the road. So, granted, a little bit after they stopped operating it, but still. Okay, so yeah, thank you everybody. And thank you to our presenters, and with that, we'll call the evening to a close.